Hello again. I had a student ask about section 3.4 and I thought I'd do a quick overview. If you have questions on any particular problems involving 3.4, please let me know, but hopefully this short video will help you get a better understanding of what's going on. Start out, I'm going to go back to old school, and you all remember in algebra classes where you learned something where it was distance equals rate times time. And the abbreviation for that is D equals RT. But one of the things I can do with distance equals rate times time is take the T, divide both sides by T, and I get this formula, rate equals distance divided by time. So if I ran 10 miles and it took me 2 hours, it would be 5 miles per hour kind of deal. And one of the things that becomes important is the labeling. So what this comes out to again is rate equals distance divided by time. My example was 10 miles, 2 hours, comes out to be a rate of 5 miles per hour. Okay, again, labeling is important. So if I take this same idea and apply it to what we're doing in section 3.4 in trig, we have the same kind of idea. Instead of the word rate, we're going to use the speed, okay? And this speed is actually the linear speed, how fast a line's going. But in the context we're using it, we're going to be going around a circle to find out what this linear speed is. Now, in the math world, we use delta a lot, and delta represents the change in. So in order to find the linear speed, we're going to use the change in distance over the change in time, which is just the same as what it was up here, which goes all the way back to distance equals rate times time. We just changed the formula. And again, this is going to be in, for example, inches per hour. You know, what is my change in distance over what is my change in time? So V represents linear speed equals S over T. Now, something that's really similar to linear is going to be angular speed. So if I go back and look at my circle, as I'm going around it, that change moving on the arc is my linear speed, and this change on the inside is my angular speed. So this guy is distance over time. This guy, angular speed, is angle over time. And again, W equals the change in the angle, which is theta, of course that's radians, over the change in time, over T. So angular speed is how fast is this angle changing with respect to time. Linear speed is how fast is this line moving with respect to time. So these two formulas, V equals ST and W equals theta T, I hope you now have a little bit better understanding of what it is. Because once you can start to identify V, ST, theta, W, you can start to put in missing pieces to find what you're looking for in problems. Now, this is number one, this is number two, and we end up with the third formula that's relating these two formulas together. Going back to section 3.2, you had S equals theta R. If you remember, circumference equal 2 pi r. That's how far did I go around the circle? The circumference is all the way around. 2 pi means going all the way around in the angle measure. And when we reduce that, we get arc length equals whatever the radian measure is times the radius in radians. So using that, I'm going to take this S equals theta R and substitute it in here. So now I get the formula V equals theta R over T, which is kind of messy looking, but this is just a middle step for this third formula because I'm going to take theta T, and replace it with W, which is my angular speed. So now I have a formula, linear speed equals angular speed times radius. So there may be times when I'm going to be given, once again, pieces of information, and I need to figure out which formula to plug it in. V, linear speed. S, change in distance. T, change in time. W was my angular speed. Theta, change in radians. So once again, as you're reading over some of these problems, you're going to be taking a look at what is the things that I'm given. I missed one. R is the radius. And a lot of times, if you read the problem, you can say, oh, they're telling me this, they're telling me that, they want me to find this. For example, they're giving me V, they're giving me R, and I want to find angular speed. Then I know what formula to plug it into. So knowing what each of the letters stand for is going to help you solve it. Knowing what each letter represents will help you figure out where to assign it to which letter. And then from there, you're probably just going to have to look for which formula is going to work. Again, if there are particular problems you'd like help with, email me or ask me to make a video showing how to solve it, and I'll post it for the class.